All right, so continuing with topic 2, Earth's frozen water and glaciers. So we're looking at glacial deposition here. So as glaciers melt and they begin to melt, they don't have enough energy to carry much sediment. So that sediment gets deposited on the land. So when glaciers slow down, there's a jumble of boulders and sand and clay and silt. It all drops from its base, and that is called till. So it's that unsorted material that's deposited by a glacier. So here, this is a till deposit. It can cover huge areas of land. A moraine, we talked a little bit about it last class. I believe I had, if I just go back here, I think I had an image, maybe not. Okay, we did talk about it a little bit. So a moraine, it's a landform that's made of a glacial till. So it's like a ridge. So till can be also deposited in front of a glacier when it stops moving forward. Unlike the till that drops from a glacier's base, this second type of deposit does not cover a wide area. And because it's made of the rocks and soil that the glacier has been pushing along, it looks like a big ridge of material, almost like it's been left behind by like a bulldozer. All right, so looking here, we have like terminal moraine, lateral moraine, a medial moraine. So again, it's that landform. It's made of glacial till. All right, that unsorted material of rock and silt and so on. Something called an outwash. When more snow melts than accumulates, the glacier starts to melt and retreat. Any material that is deposited by the meltwater from a glacier, that is called outwash. It can carry sediments and deposits them in layers, sometimes in the shape of a fan. Another type of outwash deposit, it looks like a long winding ridge. It forms beneath a melting glacier when meltwater forms a river within the ice. That river, it can carry sand and gravel, and then it deposits them within its channel. So when the glacier melts, there's a winding ridge of sand and gravel that's left behind. That's called an esker. Okay, so a winding ridge is made of sand and gravel. It's formed by streams that flow beneath a glacier. All right, so here is a retreating glacier. This here area here, an esker. Here we can see a moraine, a glacial stream, outwash plain, and a moraine, a dammed lake. So here, Okotoks in Alberta, we can see these things here called erratics. So basically glaciers, they can pick up and deposit huge rock fragments, which are called erratics. This one is in Okotoks in Alberta, carried hundreds of kilometers by glacial movement. Next, meltwater features. So meltwater, this is the runoff from melting snow. It can carve channels in and through glaciers. Some meltwater streams will flow on the surface of the ice before disappearing into the streams beneath the glacier. A mill well, it's a rounded hole in the ice that's formed by a stream as it melts its way downward through the ice. Okay, so here's just some figures showing that, like a mill well, meltwater streams, and so on. I'm just going to pause here. Next, we're going to talk about importance of glaciers. So basically, ice fields and glaciers and those year-round snows in high mountains, they act as natural reservoirs that collect snow throughout the fall, winter, and spring. Then they gradually release that reserved water as meltwater in summer. So glaciers, they feed a constant supply of meltwater into the river systems. And those river systems, they supply us with drinking water, water for farming, for irrigating crops, and water for farm animals. They also help run our hydroelectric plants. Glaciers, they also exert a direct influence on the water cycle. by slowing the passage of water through the cycle. They're also excellent storehouses of vast quantities of fresh water, and then they release that water when it's needed most during those hot, dry summer months. They also provide important clues to the past, as well as information about past climates. Just a quick video here. We're going to talk a little bit about ice ages. So ice ages, these are any of the major periods when glaciers covered much of Earth. Scientists say there's been at least 7 major periods of cooling. The most recent ice age ended about 11,000 years ago. So during that period, the climate was very different. Glaciers covered as much as 28% of the land. So striations, moraines, U-shaped valleys, erratics, those are all clues to the presence of glaciers. So from that evidence, scientists can determine where glaciers have previously existed. So ice ages and climatic change. A small change in average temperature is enough to start a chain of events that produces an ice age. So why might ice ages happen? These are some theories here. There may be occasional reductions in the thermal energy that's given off by the sun, maybe an increase in volcanic activity that will add large amounts of dust to the atmosphere that'll block the sun's energy from reaching the Earth. Periods of mountain formation would increase the area of high mountain ranges on Earth. Extra snow remaining on those cold peaks of the summer, they will reflect sunlight. That can also then reduce temperature. Movement of tectonic plates, they can alter the shape of the oceans. And then this change will affect the flow of ocean currents. Then there's less mixing between hot and cold waters, and therefore some regions might become cold enough to start an ice age. And another theory, changes in the tilt of Earth's axis or in its orbit around the sun, that can also produce colder climates. Here in this image, this is showing Mount Pinatubo in the Philippines. It erupted in 1991. The volcanic ash then cooled the temperatures around the world. Because it's blocking the sunlight. And then climatic changes today. So we know that carbon dioxide is an important gas. We exhale carbon dioxide, and then plants take in that carbon dioxide. So there's something called the natural greenhouse effect. It's just natural warming caused by the gases in our atmosphere trapping the heat. And carbon dioxide is one of the main greenhouse gases. Without that effect, life as we know it, it wouldn't be possible on Earth because Earth would be too cold to support life. So that's the natural greenhouse effect. It's very important. But global warming is causing an increase of greenhouse gases in our atmosphere. So global temperatures are rising, and many scientists think that the reason for global warming is the increase of greenhouse gases in our atmosphere. So it's increasing the greenhouse effect. And in the last 100 years, the mean or average surface temperature on Earth has increased 0.5 degrees Celsius. And if it continues to rise, the ice caps will melt. Low-lying areas will experience flooding. And already we see some ice caps are beginning to break apart. Sea level is rising in certain areas. Okay, so continuing then, how can global warming be slowed? So human activities are the major concern that are affecting the air in our atmosphere. Things that we're doing are burning fossil fuels, we're removing vegetation, we're removing trees, like deforestation. Adding carbon dioxide to the atmosphere may contribute to the global warming. So how can the amount of carbon dioxide in the atmosphere be reduced? So things like reducing the burning of fossil fuels and trees and forests, they use up that carbon dioxide. So reforestation and those kinds of things would help control the amount of carbon dioxide in the atmosphere. Okay, I'm going to pause here.